A very good morning, good afternoon and good evening to all my friends, participants and candidates for this NPTEL MOOC course, the title of which is Application of Forecasting, Regression and Time Series Models. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, as you are aware, the three broad areas for this course, which is for 30 hours, which is spread over 60 lectures and along 12 weeks, for 12 weeks. As I said, the first part is averaging techniques and forecasting, second part is regression. I have written multiple linear regression, but we will try to cover other concepts also. And the third idea is time series analysis. So, we are discussing about averaging techniques and forecasting, and this is week 5 22nd lecture, which is 5th week 2nd lecture. So, what we will cover and is basically Holt Winter Method, additive seasonality, and this we have started in the last week. I discussed lot of concepts and ideas of the nomenclature, what small s means, what capital S means, what small m means, what is alpha, beta, gamma, what is L, what is small b, all these I have repeated, and once we solve the problem it will be much simple for us to understand. I have also shown you the data which consists of the data set starting from January to December, for there are basically 4 such quarters in each year and the data was given, and I said that we will try to utilize that in details utilizing the Holt Winter methods additive models. And if we remember all the different type of symbols based on the nomenclature, how you find out the seasonality effect, how you find out the trend, how you find out the level, all the formulas were given and we will utilize that. So, few of the slides in this 22nd lecture will be repetition from 21st one, because I thought rather than going up and down in slide set, if we have a continuity of the same slides, it will be easy for all the candidates and the participants to follow. That is number one, and also it will be easier for me to explain, because I do not have to go up and down in the slides and basically go back to the 21st set of lectures and then come back to the 22nd one. So, again I am repeating, L is the level, trend is B. I am not talking about the suffix will become very clear as we do the problem. Seasonality, a concept in numbers is capital S, forecast is capital F, and we know alpha, beta, gamma are the parameters which are based for the level, trend, seasonality. You have basically the concept of small s, which is the seasonality time factor, m is how many time periods ahead you are going to forecast, and it is the additive model. These are the values again, and obviously the main idea is to minimize the errors. I am just showing the slides because they have been discussed time and again, they have been discussed also in 21st lecture. These are the assumed values. I did tell you that we will keep changing the values accordingly based on the factor that we will be taking the values of alpha, beta, gamma, changing it and doing the problem. And these are the starting values where LS has been defined, BS has been defined, and capital S1 to capital SS has been defined accordingly as based on the formulas. Now, we will solve the problem. So, this slide which is being shown to you along with the definitions of what are the different variables, we will be utilizing interchangeably. Now, I go back to the Excel sheet and here is the data. What the data is, and this is basically, as you can see, here is the model which is Holt Winter's additive model, and what are written here column wise. S is, if you remember, it is 4 months, alpha is the value which you will utilize for level, beta is the value or parameter which you will use for trend, and gamma is basically for the seasonality. We are going to take, which will keep changing, 0.95 for alpha, 0.4 for beta and 0 for gamma. M, how many time factors later you are going to predict, we will take as m is equal to 1. Now, if you remember, as seasonality is 4, hence we need to find out the value of the concept based on L4. So, we will basically have L4, we will basically have B4, because B suffix 4 is for the seasonality. You have, if you remember, you have taken seasonality concept of capital S1 to capital SS. So, S is basically a time frame of the seasonality. So, it will now here it will be S1, S2, S3, S4 as mentioned here, which I am just highlighting S1, S2, S3, S4. Now, considering the concept that how we will use, we are, as he said, that we will basically do one seasonality check and then try to basically replicate the data accordingly. Now, let us start the problems here. Now, here L4 is what, and it is given. L4 is basically the average value of, when you are starting the first 4 quarter, which is for year 1, the values of yt to y4 are given as 362, 385, 432 and 341, which is basically, as if you remember, I mentioned the period, which is for period 1, 2, 3, 4, which is for quarter 1 for year 1, quarter 2 for year 1, quarter 3 for year 1, quarter 4 for year 1. So, addition of these values basically comes out to be 380, and 380 is the value which you have for L4, and you see it here is the average we are taking. And from where you are getting the average? Based on what concept? Here, the first point, average of all y values in the seasonal time frame we are considering. So, L4, S is small s is 4. So, it will be 1 by 4, and it is y1 to y4, and y1 to y4 for the seasonal concept is given. Again I am repeating 362, 385, 432, 341, and where these values are, they are given in the first year quarter 1, first year quarter 2, first year quarter 3, first year quarter 4. So, this will come for the concept of LT, which is the first value. That is why it is marked as red here, and the arrow basically gives it from the data calculated is coming back to which point. Now, I need to find out B4 or BS. So, BS value is given by the average. So, S small s is 4, so it will be 1 by 4, and what we do is that we find out the difference of y s plus 1 minus y 1 divided by s, and we continue. So, here what we are doing? We are considering, if you see this formula, it is y 5 minus y 1. So, y 5 minus y 1 would be 382. So, if I go back to this value, it is here, if you see, is 240, J 244 minus J 240. So, J 244 is basically 382 minus 362. That difference basically you find out and divide by 4, because there are 4 time periods. Then you find out y 6 minus y 2. Y 6 minus y 2, if you see, is J 245 minus J 241. So, J 245 is basically the value of 409 minus 385. So, you are moving in block. First with corresponding to the 5th, then second with corresponding to the 6th, third corresponding to the 7th, and fourth corresponding to the 8th, because there are 4 blocks. So, basically you find it out. The third value would be as given in the, all calculations are done in Excel, so you would not have any problem. The third value would be J 246. Here J 246 minus 242. So, J 246 is this value 498 minus 242 is basically 341, difference of that divided by 4, because 4 is basically small s. And the last value would basically be J value of 246 is 247 minus 243, which will basically be the difference between 387 minus 341, again divided by 4. You add them all values up and divide by 4, that value comes out to be here 9.75. So, 9.75 means for that season before, which is the trend in that season is about 9.75, which is shown here in blue color. That is the so called trend average value for those 4 seasons. So, this is the factor which you are trying to basically, and this is positive, so it is increasing. Now comes the concept of the values of seasonality, and if you remember, the values of seasonality are, I go back to the formula. So, it will be S1 will be Y1 by Ls, S2 will be Y2 by Ls, till the last term which is S4 will be Y4 by Ls. And what are these? These are the concepts of the actual value Y1 divided by the L, which is the level. So, it is basically being adjusted based on the level on an average. So, if I consider the values, here it is. S1 would basically be the value of J40. J40 is basically the value which is 362, which is Y1, divided by L327, which is basically the L4 value, which is 380. Similarly, the next value S2 would basically the value of 385, which is Y2, divided by 380, which is L4. The next value would be basically 432, which is L3 divided by L4, which is 380. And the last value would basically be 341 minus 380. So, based on that, when I find out the values, the corresponding S1, S2, S3, S4. So, these are capital S1, capital S2, capital S3, capital S4. Values come out to be, I am only reading the first two decimal places and they are being marked with a color purposefully. So, S1 is 0.95, S2 is 1.01, S3 is 1.13, S4 is 0.89, and these values come for that time period which are marked in the column M, which is basically ST. So, here they come, the colors have been given there, the arrows also are there. So, 0.95 comes here, 1.10 comes here, which is pink in color, 1.13 is basically light sea blue in color, and 0.89 is about brown in color. So, once that is done, we have these values accordingly, and if you see, the formula of S1 is Y1 divided by L4, for S2 is Y2 divided by L4, S3 is Y3 by L4, and S4 is Y4 by L4. It is written for explicit understanding for all of us. Now, given this, I need to be, so I have utilized the starting values, everything is done. I have considered some alpha, beta, gamma values, I have taken M as 1. So, initially again I am repeating, L4 found out, B4 found out, S1, S2, S3, S4 all found out based on the concept. We have considered alpha as 0.95, we have considered beta as 0.4, we have considered gamma as 0, and we have considered M as 1. Now, we need to proceed. Now, the procedure would basically be based on the fact that we need to go back to this slide. So, that is why I said running to and fro between 22nd and 21st would not look nice. So, hence I have brought all the important concepts which are to be utilized for solving this problem. The slides are there in this 22nd lecture. So, level would be calculated by this value, LT is equal to alpha into YT minus ST minus S. So, which would be, let us go one by one. So, LT next value, if you see, which is H237, H237 is alpha value multiplied by J244. J244 is basically the value of Y5. So, that value where we are trying to find out, which is basically YT, and ST minus S is basically given by the value of M20. M20 is given by the value of M240, sorry, M240 is given by this value which is here. That means, I am trying to find out the actual value minus the so called factor of seasonality, and that would be multiplied by alpha based on the concept of weightages I am going to give. That is part 1. Part 2 would be 1 minus alpha. Here you see 1 minus alpha, and it will be LT minus 1, BT minus 1. LT minus 1 would basically be this value which you have taken 380. So, if I go back here, it will be 1 minus alpha plus 243, 243 is K, 243 is 380 minus L 243, L243 is basically the value of here Bt minus 1. Bt minus 1 we already have, is given by the concept of the factor which is here, one step back. So, once I have this, I have LT. Trend is given by what is the formula? Beta into LT minus 1. So, LT minus 1 would be K244 minus 243, which is 381.483 minus 380. That is the first part. Second part is 1 minus beta into Bt minus 1. So, 1 minus beta is basically 1 minus 0.4 into L243, and if you consider 243 is basically the value of beta value one step backwards, one step in the past. So, I have found out beta t. Now, I need to find out the seasonality, which is seasonal factor, which is given by gamma into yt minus lt, and gamma is given as 0, yt. Oh, here basically we are just 1 minute. Factor of S would basically be given by SI would be given by yi by Ls, and it is an additive model. So, it will be divided. So, additive means divided, and seasonality concept would be basically in the case of multiplicative we will consider it accordingly. So, if I consider this, I have the concept of here given the idea that we are considering the factor of to find out ST, and given ST I need to forecast, which is the fourth bullet point, which is LT plus BT into M plus STS T minus S plus M. Small s is 4, M is 1, remember. So, once we have that, we utilize the formula given here, which is K244. K244 is basically the value of LT, which is true as given in this formula. I am just hovering the cursor here, plus BT into M. So, BT value if you consider is L244. L244 value is known as BT is 6.443 multiplied by K237. K237 would be M, which is 1. We know that, we have assumed that, plus the value of ST minus S plus M. So, ST minus 4 plus 1, which is ST minus 3. So, ST minus 3 is basically given by the value of M 241, which is already there, which value which you know is given accordingly, 241, yes, which is S3. So, it would be T minus 4 plus 1 minus 4 is plus 1 is T minus 3. So, T minus 3 obviously would be yes, correct. So, basically I am going 3 times step backwards, it will be 1.01316. So, based on that I find out FT, then I find out the difference of YT and FT, which is column J and N. Based on that I find out the error, and I replicate the values accordingly, I have the errors. So, let us assume I change the values of alpha just for simplicity. So, until unless you solve the problem using the Excel sheet, things would not be absolutely crystal clear. So, my explanation, my utilization of the detailed PPT slides and also the Excel sheet is fine, but please once you have the Excel sheet, please play with it, change the data and try to find out, and if there is any query, any questions which is there, definitely ask the TAs, and they, I am sure they will be able to help you out accordingly. So, let me change the value of alpha and keep a note on these errors here, which is basically in the column O here, this is column O. So, basically if I change 0.4, the value changes from minus 6 to minus 12. If I change beta, say for example 0.6, the value changes from minus 16 to minus 12. So, I can keep changing the values, but what is the main task? Main task is based on the fact that I need to basically minimize the errors. So, let us do a simple concept. So, if I consider the value of 0.882 for alpha and a value of beta as 0.055. Why I am doing that, I will come to that later, and gamma as 0. So, if you see here, these are the values which have already been plotted. So, here I will mark in yellow. So, if I click on the first one, if you see, the values of alpha is 0.882 and beta is 0.055, gamma is 0. So, if I change these values in this equation, so I have the error which is given here 10 point minus 10.415, which is here in this cell. So, if I change the value of, say for example, and I have these values. So, the next value is minus 8.299, this is here minus 8.299. So, in the next value is minus 4.285, the next value is minus 4.285. So, based on that, again I can keep changing the values of alpha and beta. So, let us consider alpha as 0.7, beta as 0.07, 0.7 and 0.07. See, if I have this, I have the errors which are there. So, the errors are here, this minus 11.995 is here also. I have just copied it. So, I have done it before, already saved for trying to basically save time of explanation. So, that is why I am just highlighting is plus 11.0937 plus 11.0937, minus 39.273 minus 39.273. So, if I keep changing, I have these 4 values of alpha, beta, gamma. What are these? They are highlighted in yellow. So, alpha is 0.882, beta, and for the first set is beta is 0.055, gamma is 0. Next one is alpha is 0.7, beta is 0.07, gamma is 0. Next value is alpha is 0.2, beta is 0.03, gamma is 0. Next value is alpha is 0.95, beta is 0.4, gamma is 0. So, based on that, I have the errors for this set of data. Now, let us draw it, and obviously, the time frame or the quarters would be, or the time period which is given would be there on the x axis. So, I plot it, and here are the curves. Series 1 is basically for the first combination of alpha, beta, gamma, so on and so forth. So, if you see there is a, for the brown gray one which is series 3, there is a huge amount of fluctuation. For the blue one which is series 1 is the least, which means the combination of gamma is alpha is equal to 0.882 and beta is equal to 0.055. For these 4 combination is giving the least error. Now, the question would be, can we do this problem considering other ideas of, say for example, U statistics, other ideas of mean absolute error, other idea of percentage error, other idea of weighted percentage error, U statistics, as I mentioned U statistics? Answer is yes, we can do that, and that is basically left to the students, because given all the data information which you have, I am sure you can play with the data and can definitely have a lot of information to help you out. Now, I go back to the slides which we were discussing. So, this again I am repeating, sorry for trying to basically repeat it time and again. L, I am not reading the suffix L, the level B trend is B seasonal, value is capital S, forecast is capital F, and you have alpha, beta, gamma corresponding to the so called weights given for level, trend, seasonality, and you have suffix T for the time, small s as the seasonal factor based on time, M is how many time periods ahead you are going to forecast. These I have already explained, we have assumed these values, just I showed in the Excel sheet, and these are starting values, the concept is already explained in the Excel sheet, and based on that, this Excel sheet problem which I did have been copy pasted here for flow of the discussion. So, as you keep changing the values of alpha, beta, gamma, you can get different values of error, different values of U statistics and all these things. But this slide had been made such that at one go you can understand what are the values which are being considered, and here also for simplicity, if you see this highlighted fact is marked also. Given means from the data, assumed its quarters are assumed 1, 2, 3, 4, then period is assumed 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This yt is basically the actual values. LT basically is found out the level, beta the trend as the time period, and here the calculations, this y1 plus y2 plus y3 plus y4 divided by 4 is for L4. Similarly, B4 is found out. Similarly, capital S1, capital S2, capital S3, capital S4 are found out, and the formulas are given. Again I am repeating, S1 is y1 plus L4, S2 is y2 plus L4, S3 is y3 plus L4, S4 is y4 not plus, sorry, divided by L4, my mistake. Again I repeat, capital S1 is y1 divided by L4, capital S2 is y2 divided by L4, capital S3 is equal to y3 by L4, and capital S4 is y4 by L4. So, here I have the data set, and if you remember the data set which I have shown, if I find out the mean error, here it is the interesting fact I have shown in the diagram. So, the mean error R is as follows. This is the there I have shown the fluctuation, here is the mean error. For the first instant, alpha 0.82, beta 0.055, gamma is 0, the value comes out to minus 13. For value of alpha 0.7, beta 0.7, gamma 0, minus 13. So, value is difference in the second decimal is very small, which is the second column. In the third column, which is alpha 0.2, beta 0.3, gamma 0, it is plus 12. And for the fourth column, it is basically alpha 0.95, beta 0.4, gamma is 0, the value comes out to minus 17. So, obviously, you will be tempted to basically give the value of the third column, which is alpha 0.2, beta 0.3 and gamma 0, because the overall sum of the error is 12, which is good, fine. But there can be other statistic which can give you other models to be true, or else they can be combinations of alpha, beta, gamma, which may give better results even for the case of the sum of the errors. So, the idea is basically once you are certain which model will be used, try to basically utilize all the statistics to be 100% sure that the model which you are trying to use is the best. It may not be the perfect, but it should be the best in order to solve the problem. So, with this I will end the 22nd lecture and continue more discussions in the area of forecasting utilizing, if time permits. Obviously, I will try to do more detailed analysis of another Holt Winter additive model, but obviously that can only be taken up once we do the Holt Winter multiplicative model. So, hopefully, we will be able to wrap up at least the Holt Winter multiplicative model within another 2 lectures, and in the last class for this or a last lecture for the 5th week, a very short summary with few other important highlighted points I will try to cover for forecasting model, and most probably with almost certainty I will definitely start the regression model from the 6th week. Thank you very much for your attention and have a nice day.